In this video, we're computing the derivative of the inverse sine of x. So whenever you're dealing with an inverse function, the best first step is to give a name to this thing. So we're going to say y is equal to the inverse sine of x. Now there's a really useful way of reading inverse functions. I'm going to say y is the angle whose sine is x. And with y being the angle whose sine is x, well, I can just say the sine of y is equal to x. So now what we're going to do is take the derivative with respect to x on both sides of this equation, because if two functions are equal, their derivatives have to be equal as well. So I have the derivative with respect to x of sine y is equal to the derivative with respect to x of x. And it's really important to realize that what we're looking at here on the left-hand side is a function composition. We know that y is a function of x. It's the inverse sine of x. So what I'm looking at on the left-hand side is the sine of a function of x, and this requires that we use the chain rule. So in calculus textbooks, this is often called implicit differentiation, but it's really just another manifestation of the chain rule. So derivative with respect to x of sine y, the way I start out is by taking the derivative with respect to y, and that gives me the cosine of y. Then I have to tack on the derivative of the interior function with respect to x, and that's dy dx. And dy dx is exactly what we're looking for in this problem, the derivative of the inverse sine function with respect to x. Okay, on the right-hand side of our equation, we have the x derivative of x, which is just 1. So we're going to solve for dy dx. Again, that's the derivative of the inverse sine function. That's what we want in this problem. And on the right-hand side, I'm left with 1 over cosine y. You could leave it that way, or you could express it as the secant of y. But either way you do it is about the same amount of work. And the next thing I want to do here is replace the y with its definition. Y is the inverse sine of x. So I end up with 1 over the cosine of the inverse sine of x. And again, that inverse sine of x is an angle. It's the angle whose sine is x. So we're left with this classic situation where we have to compute a trig function of an inverse trig function, the cosine of the angle whose sine is x. And my favorite way to do this is to just visualize the angle whose sine is x in a right triangle. So again, we're trying to visualize the angle whose sine is x. So I'm just going to make that this angle right here. And the simplest way to make that happen is to make the opposite side x and the hypotenuse 1. Now to get the cosine of this angle, we need to know what the adjacent side is. And you find that by enforcing the Pythagorean theorem. With a little bit of experience, you can probably guess what this side is. It's actually going to be the square root of 1 minus x squared. So that if I square that leg and add it to the square of the other leg, I should get the square of the hypotenuse. So just checking my answer real quick. If I square the square root of 1 minus x squared, I get 1 minus x squared. And then if I add x squared to that, I do indeed get 1, and the Pythagorean theorem checks out. Now, if you're not comfortable doing kind of a guess and check game with that, then you can always give this missing side a name, and I'm just going to call that question mark. And then we write down the Pythagorean theorem, question mark squared plus x squared is equal to 1 squared. 1 squared, of course, is just 1. So we solve for question mark squared, and that's 1 minus x squared. And then we square root both sides, and we have our question mark. Again, that's the square root of 1 minus x squared. Okay, with that figured out, we can get back to this expression that we were trying to evaluate. So remember, dy dx is exactly what we're looking for. That's the derivative of the inverse sine function with respect to x. And it turned out to be 1 over the cosine of the angle whose sine is x. And we've labeled the angle whose sine is x over here. And we found the adjacent side in that triangle. And so the cosine is adjacent over hypotenuse, which is going to be square root 1 minus x squared divided by 1. And of course, dividing by 1 doesn't do anything. So we have down here the square root of 1 minus x squared for the cosine of the angle whose sine is x. And that's our final expression for the derivative of the inverse sine function. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.